Hi folks, let's take a few minutes and talk about the idea of standard I/O and what this model means in Linux. I'm going to jump back and forth a little bit in this discussion between the PowerPoint slides and a terminal to illustrate a few things, so bear with me as the output kind of jumps around. So let's talk about standard I/O. And I'd like to start with the first thing is a kind of a cardinal rule. This is something you can pretty much live by, which is this. Everything in Linux is a file. And then I have an annotation there that says, well, most everything. My point is right now, as far as you and I are concerned, everything that lives in the Linux world can be viewed and treated as a file. This idea of everything being a file is central to how elegant, minimalist, stripped down, and accessible everything in Linux is. I mean, this is true of Unix. This is where all these ideas came from, but we're looking at the implementation of Linux, so I'll use that term. This does not exist in Windows. It really doesn't exist all that gracefully at the front end of Mac OS either. Although behind the scenes, we all know that Mac OS is also built on a BSD Unix framework, so the underpinnings are all there. But as far as we're concerned, everything is a file. It is a plain text file. You can get to things through it. You don't have any of this ugly mess like you have with the Windows registry, for example. But we'll come back to that later. Let's look at some more prosaic examples, if you will. The first thing here is this third slide has the notion that we have this idea of the standard I/O model. So in my little diagram here, we see that at the center there is a process, and that's any Linux process. You can be executing a command, a program that you have written, a shell script, it doesn't matter. That process, when it runs, has a notion of 3 separate files that it can deal with. By default, if you exist as a Linux process, you have these files associated with you. From the left-hand side, there is the standard input, and I'm going to define these in simple and yet practical terms, which is standard input is where you get your data from. It's the input to a process. On the right-hand side of that process box, as you see, standard output. That is where output goes, the standard output that your command generates. And finally, there is a notion of a standard error file, which is where error messages, as you might expect, are written. So let's talk for a second about standard output. Okay, it's the file to which all normal output of a process is written. If you're in a shell, that defaults to the terminal itself. So let's use an example. You see, I have an example here that says cat, a file called quote.txt. So let me bring up a terminal here. And in my terminal, I have a file there called quote.txt. So if I execute the cat command and say cat quote.txt, it spits out the contents of that file. That's what the cat command does. We'll go look at the man page for that in just a second. In that file, I just have a quote from Abraham Maslow, who, if you've taken any sociology, anthropology, psychology class, you've probably run into Maslow and his hierarchy. And so this is a favorite quote of mine that says, if the only tool you have is a hammer, you tend to see every problem as a nail. Good advice for all programmers and techie people. I mean, one of our main goals in life, just to make a quick aside, is that we're out to get as many tools as we can have, because all of our problems are not nails. All right, so that's what the cat command does. In fact, if I do a man on cat, notice what the name says. Cat. Concatenate files and print to the standard output. This is the standard out I'm talking about. So by default, it will print to the terminal. And if you notice that in the synopsis it says cat could be followed by an option, which could be followed by a file. So if you give it a file name, this is the file that will be concatenated or spit out, if you will, to standard output. And so when I say cat quote.txt, that's exactly what's happening here. Now, I don't have to have this be just the terminal. I can redirect it. And I'm going to jump back to the PowerPoint here for just a sec. You see my last bullet there says you can redirect using the greater than sign. So let's do an example of that. Or I could say cat quote.txt and then follow it with a greater than sign. Now I'm going to follow it and say write to a file called foo. It's simple, short name, and geeks like to use it. You notice when I execute this, I don't get anything to my output. Nothing shows up immediately, rather, on the screen. But if I do a listing of the directory, I suddenly see now that I have a file called foo. And if I look at the byte count, by the way, it's identical to quote.txt. So if I actually turn around and use cat again to cat out the file foo, you'll see that what I have is exactly the same contents as quote.txt. Everything got written to foo. I can certainly cat it again and put it out to another file called foo2, do a listing, let's do a long listing, and you'll see that now I have a foo2. So this is just the ability to redirect the output to one or more files. For the sake of clarity, I'm going to remove foo, and I'm going to remove foo2 as well, so I can come back and start off in my normal state again. All right, so that's a quick view of the standard out. And oh, by the way, when I do this command, cat to foo or foo2, that redirection only occurs for the existence of this command. In other words, not all of my subsequent commands are going to write to foo2, just this process. This lives for this process only. Okay, let's go back to the PowerPoint for just a sec. And we'll go to the next file, standard error. Now this is a file where all normal errors from a process are written. And just like standard output in a shell, it defaults to the terminal itself. So in my example here, I have I'm showing a command of cat qt.text, which we know doesn't exist. So if I jump it back to my terminal and try that, and I say cat qt or anything, you notice that I get a message that says cat qt, no such file or directory. Pretty simple. Now it appears to us right now that this came to the same place as standard out, but it's not. This is actually standard error. At the moment, by default, both standard out, standard error show up or are designated as the terminal. Therefore, the output appears to be in the same place. So how can we prove that this is not quite the case? One thing I can do is run this command again, cat qt, but this time instead of directing it to the, I'm going to not let the output or for standard error default to the terminal, I'm going to say redirect it to another file. This nomenclature of the number 2 greater than says really what 2 is a number that the shell knows to be, in this context, standard error. So I'm redirecting standard error to something called, I'll just call it ERR. You notice when I execute this one, I don't get any output that shows up. This is the same command I had a moment ago that put out the message that said, up here, qt, no such file or directory. Well, let's do a long listing and look at, I now have a file called error in this listing. You notice that error happens to have byte count of 35. Well, we'll just use cat itself again to cat out the contents of error. Notice that now I see that error message. So the standard error can default to your terminal, or it can go to a file that you would want to designate. Let's remove error, and let's do a count of quote.txt and say let's redirect to ERR. So just in case there's an error, while I run this, I get the standard output, if the only tool you have, and standard error has been redirected. Did we get a file from this? Well, I do a long listing, and in fact I do see that there is a file called error, but notice that its byte count is 0. It's an empty file. How do I really prove that? Well, I can always cat ERR out, and notice that I get no output. Even though nothing was written to ERR because there was no error in this last message, the file still exists because the process created it. Basically, when this command, this command right here ran, the process says, well, I'm going to open up a file to write to it called ERR in case I need to write to it, but I didn't. Since nothing went out to the file when the process terminated, the file was left there. It does exist. Now, if I ran this again to my example that had cat of qt write to error, nothing comes out, but this time if I cat error, it contains the message. Every time this overwrites the previous file. And we'll talk about ways to overwrite versus append or continue to write more and more data to a file while keeping the existing data. We'll look at that a little bit later. I just wanted to get a quick feel for the standard error. Let's revisit the man page on cat for just a second and then talk about this last thing, which is standard N. If we read through here, it says concatenate right to the files out on the screen. I'm going to jump down by hitting the space bar. And I want to draw your attention to this last line here before the examples. It says, with no file, or when the file is dash, read standard input. What does that mean? Well, if I do a cat by itself, you notice that nothing shows up on the screen, nothing comes out, but you also notice that I don't get returned to my prompt. At this moment, cat is reading input. Is reading the standard input. Just like standard output, standard error, by default, standard input is the terminal itself. So I can say things like, hello Maslow. You notice as soon as I hit a return, hello Maslow prints out again because cat's job is to do what? Take whatever its input was, write it to standard output. That's why I'm seeing the echo. Now this will continue to sit here and wait for more input, echo that out until something tells it to end. Our quick way to have it to end is to send it the standard into file character sequence, which happens to be a control D. So hold down the control key, hit a D, and this quits. So that's an example of the standard input. Now, this model applies very elegantly to almost every command ever written. As you read in the textbook, he constantly comes back to the fact that all of these Linux shell commands and utilities are all very small, do one very specific thing. But the great thing is that they have the ability to connect to each other. And we're going to talk more, in chapter 15 talks about this some too, but I want to do an introduction. But it's the fact that I can chain commands together by using standard input and standard output and a couple of other really nice operators to really act a lot like Lego blocks, so you can start to connect things together and build bigger and bigger, specialized and more powerful utilities. I can't overemphasize the elegance and minimalism of this and how useful and how well this has stood up for over all the years. At the outset, all of this syntax looks kind of terse and kind of cryptic, and I'll agree with you on that. But the payoff for that is that you have a very stripped down, very simple syntax that lets you connect these things together. So this is just an overview of the standard I/O model, but it's a really useful thing at this point in our lives in learning Unix, Linux, that having this idea of these standard input, output, and error files is going to make it a lot handier to understand a lot of the utilities and commands we're about to learn next. So that's all for now. Thanks so much for your time, and I'll catch you guys on the forums and email. Thanks.